So in class we went over the formation of an acetal, starting with an aldehyde and turning that into an acetal by acid catalysis. What we didn't go over is the process of acetal hydrolysis, which is simply the reaction in reverse. So I want to go over that mechanism with you guys so that you're ready to draw that. So here we're going to start with a benzaldehyde-based acetal. We're going to use this cyclic acetal as our starting material. Right? And we're going to treat this under acid catalysis. So general acid catalysis is represented by the H plus in brackets, and this is done in the presence of water. Okay? And the result of this reaction will be the formation of benzaldehyde, and the byproduct will be the diol that we released from our acetal. Okay? So in this mechanism, first step is going to be protonation of our acetal. Okay? So we're going to use H plus as our proton source. Remember, all of these steps are equilibrium steps, so they go forwards and backwards. All right? So in the first step, we are going to protonate one of the oxygens in our acetal by taking a lone pair on oxygen, having it grab the hydrogen, right? Which leads us to a protonated intermediate. Okay? This protonated intermediate now, we're going to take a lone pair on the other oxygen, and we are going to push that down in order to form a CO double bond. And at the same time, we're going to take the other CO bond, and we're going to push those electrons towards the positive charge on oxygen. So now we have CO double bond. That oxygen still has a bond wrapping around to the other oxygen. Right? So we have a positive charge here. Okay? Next step, we have what looks like an activated carbonyl, where we have a positive charge on oxygen that's part of a CO double bond. So in the next step of our mechanism, we're going to take one molecule of water, and that's going to act as nucleophile. So here, we're going to have nucleophilic attack of water on the carbonyl carbon, and we're going to push the electrons up towards that positive charge. Right? This leads us to our next intermediate. Where we have our water molecule with a bond to carbon, and it is still positively charged. Okay. Next step of the mechanism will be a proton transfer, right, to get to a neutral structure. So here, our best base under these conditions is going to be another water molecule. So we'll draw out water and have water deprotonate one of these extra hydrogens here, pushing these electrons towards our oxygen, right? And that leads us to another neutral intermediate. Okay? So ultimately, we are trying to get rid of this diol here, right? So what we're going to have to do in our next mechanistic step is yet another proton transfer. This time we're going to activate this ether as a leaving group. So we're going to take our hydrogen, we're going to take one of the lone pairs and have it protonate our oxygen. Right? And so now this ether is activated so that we can have it leave, and we're going to use the lone pairs on the adjacent oxygen to help that leave. So we're going to push down one of these lone pairs to form a pi bond between the oxygen and the carbon, and then we're going to have our ethylene glycol molecule leave. All right, so next step, we're almost to the end where we have our benzaldehyde, except it's now simply protonated, and our byproduct of this reaction will be that diol, right? And that's going to float away and not participate in the reaction anymore, right? So the last step of this reaction is going to be yet another proton transfer. So here we're going to use a water molecule. Our water molecule is going to deprotonate that extra hydrogen, and we're going to push those electrons towards that positively charged oxygen, and that's going to produce our desired product, which is the benzaldehyde. Right? So this is the same number of steps as the acetal formation. They're simply in reverse. So just going over all the steps we did. The first step was a proton transfer. Right? The second step was loss of a leaving group. Although our leaving group didn't go completely away, we did break this carbon-oxygen bond. Okay. Third step, we formed this activated carbonyl compound. So then we had nucleophilic attack of water. In our next step, we took our protonated intermediate and turned it into a neutral intermediate. So we had a proton transfer. Right. We moved this proton ultimately to this position. So one proton transfer to deprotonate, another proton transfer to protonate again. When we do this proton transfer, we've now activated this ether, this side of the acetal, so that it can leave. So here we're going to have loss of a leaving group. So we're going to use the oxygen's lone pair to assist in that. Okay. And our last step here, we're simply taking our protonated aldehyde and converting it to our aldehyde. So yet another proton transfer. All right. So these 7 steps convert an acetal into our aldehyde product.